Welcome everybody. My great pleasure to be hosting you, and very proud to have Mike, who I'll introduce in a while, who will be moderating this first panel session in webinar format. The Q&A part is already open, so I have my eye on it, so don't hesitate if you want us to go some particular direction. Let me just tell you in a few words what this session is about. It's about reinventing streaming on the internet to address sustainability concerns. There's a lot of people working on it. We don't quite know how big the problem is, but we know it's big. We are talking terawatts of power being used, however you measure it. And there's a potential for our digital lives, which today create about 4% of the carbon in the world. That could easily rise to 15% in the next few years if we're not careful. So there's a lot of things happening. This session will just open some avenues of thought to how these things may change. We're going to have one speaker tell us about looking quite far ahead, how we might reinvent the way we do the whole thing. And then we're going to have two speakers give us some ideas of what we can actually do today in 2023 and various more focused on solutions that exist today. So the order of events will be, I'll have a quick discussion with Mike about what's wrong, why we need to fix things. Then Mike will take a discussion with Arian Koster of TNO about the more future-looking solution of reinventing streaming. Then Pieter from Broadpeak will discuss again with Mike how multicast adaptive bitrate might be part of the solution, but he'll also give a much wider view as well. And that first rather controlled part of this session will finish off with Mike discussing with Dan from ATEME what an audience-aware approach to streaming might bring us in terms of more sustainability. And then we should have time, if we manage to control things, for a good 15-20 minutes at the end. That depends on Mike's abilities. And just one final thing before I hand over to Mike, to say that at the last session, those of you who are here, you remember we had a group brainstorming about what the rest of this series will bring. So if there's time at the end of this session, otherwise in the second hour, I will just give you a teeny bit of feedback on that so that you know what to expect for the rest of the year. Quick roundtable before we start. So let's go clockwise, what I can see, finishing with Mike. So start with you, Dan, if you could just give us 2 words about yourself.
Hey, good afternoon to everyone, or good morning for the folks in North America. My name is Dan Patton. I'm Vice President of Content Delivery Solutions for ATEME, and I look forward to the session.
Yeah, so hi everyone, my name is Pieter Liefooghe. I am part of the Broadpeak business development team. For those who do not know Broadpeak is specialized in media delivery technology and more specifically streaming.
So I'm Ben Schwartz, behind this whole initiative with Janet. I was a software developer for 10 years. I spent 10 years at Orange working on streaming subjects, and I've been an independent consultant, specialist in this area for the last 15 years, writing white papers, particularly for people like Broadpeak, ATEME Harmonic. And over to you, Arian.
Okay, yeah, I am Arian Koster, working at TNO, which is a Dutch applied research lab. And I have been working for over 30 years in the media industry. Before I joined TNO to the networks and media department, I was working for KPN, busy in deploying IPTV the last 15 years of my life there.
Fantastic. So Ben, I'm going to jump on in and take the reins for a quick minute. First off, good morning, good afternoon, good evening to our listeners and participants. Today, I think, is going to be very exciting. Just a quick background about myself. I've been working in-home architecture for going on 40 years. I've been through numbers of video deployments, both legacy QAM systems, IPTV, over the top, and kind of what's been happening new recently is all the video content coming in from subscribers. So I think as we look at sustainability across the world, the real focus is how do we become more efficient on how we get content out to the consumers of content. And I think, Ben, as we look at this problem today, we want to take into account some of the legacy systems that are still in place over there, some of the transformation that's happening across the industry. When we say legacy systems, there are still legacy systems based on QAM architecture. There is legacy IPTV that is still alive and well across the world. We have over-the-top content, which is really, in my opinion, probably changing viewing habits for a lot of individuals out there that used to be very tied to their TV sets on a certain timeline and time frame, to now providing content that is generally available when they want to watch it. But we do not want to forget about all the additional video content that's coming from these platforms out there, Instagram, TikTok, et cetera, et cetera, et cetera, that potentially is using the internet in a little bit different way as we initially look at downstream traffic driving content to the consumer. We now have content creation coming from the consumer being distributed across the internet. I think we're going to have an exciting session with Arian in a minute or two. Is the internet really designed wrong? Do we need to reinvent the internet? Or maybe we just need to change the way the OSI model works and how we talk about changing packets across the internet. And I think there's some exciting opportunities there. Ben.
Yeah, so that amazing intro, Mike. What I wanted to talk about for a few minutes is with Janet, we looked at our audience. I know there's all sorts of people. So those of you who've been doing the internet for the last 30, 40 years, you may not learn much in the next minute or two, but hang on. You will thereafter. I just wanted to remind people of the genesis of the internet. I mean, basically, it all started in President Eisenhower's office in 1958. When we're talking about where does it come from, in the middle of the Cold War, we need something in case we get nuked by the Russians, so the army can continue to send data to different parts of each other. I mean, that is the basic requirements. The high-level spec of today's internet is still the same. It was designed to be able to send small pieces of information even when the country's being nuked. And so one thing that came out of that, you just gave the word, Mike, is packet switching. So I don't want to explain that to the non-techies, but just understand that there were multiple ways we could have done this, and it was designed in the 60s, during the 60s, the first papers in the early 60s, and it was kind of formalized in the late 60s. We put data into packets. So rather than just have an ongoing stream of data, we talk about streams of data, but it's actually packets of data going down these streams. The stream isn't a very good image. It's lots of little packets going. And one of the issues with packets is that you need to wrap things up. And so there's obviously a significant overhead, but it doesn't really matter when you've got small amounts of data. But then when you start having things like video, that is part of the issue. It was designed for text, not for video. So the whole concept of packets is quite complicated because it doesn't really work with huge, big packets. But so the war aspect was answered by the fact that, do we actually need this in today's internet? But I mean, do we need to withstand parts of the country being nuked? And do we need it? So that's something that I think Arian will address. And the text part is why video is so hard. And just a quick reminder for those of you who CDNs, so content delivery networks, they kind of accompanied the internet's development, or the World Wide Web, which sits on the internet, starting around the turn of the century. I mean, they started a little bit before, obviously, but they became really prominent and needed because we had these little images, and you used to get the New York Times that would publish something on their website, and there'd be a little image there. And if you wanted to load that page, it would take forever unless there was a CDN somewhere closer. And they were just designed originally for small, a few tens of bits, hundreds, then maybe a few thousand bits. That's where they started life. And then sort of beginning of this century, lots of attempts were made, even in the 90s, to do streaming. And some of them were actually moderately successful. One of the issues, they had to choose between scalability and quality. Either they could kind of do a relatively nice experience. You could actually kind of watch bits of video, but it was totally unscalable. We could serve a few hundred to a few thousand people, not even hundreds of thousands. Or it could scale, but it was crap in terms of quality. And this kept on, going and trying new things until just over 15 years ago, there was a disruptive invention, something new actually happens. Sometimes it's not just evolution. There was the day before and the day after, which is what we're going to talk about. At least Peter's going to talk about multicast ABR. I'm just going to talk about ABR, adaptive bit rate. In what we're talking about was a major revolution, invention, whatever. It basically allowed both quality and scalability to finally reach, and it's taken us 15 years to get to where we are now, where we get millions of people that can watch Netflix and stuff like that. And so that was the first thing that solved the dichotomy. And then all of a sudden, remember I talked about CDNs a couple of sentences ago, all of a sudden CDNs woke up and said, hey, we can be the champions of video delivery, because one of the things that ABR does is it pretends video isn't video. It just pretends it's regular data and sends it around like regular data. And so all of a sudden CDNs, which weren't originally designed for video, they were designed for packets of data. They say, hey, we can do this, and they can do. And so now, if you're going to stream a live match of the World Cup or something, you have to talk to the Akamais of this world and stuff like that, because they've all of a sudden become front and center of everything to do with video delivery because of ABR. Just to finish off this intro, there's an interesting talk that I had at the last IBC with an analyst saying, well, perhaps ABR was a fantastic revolution that solved our problems in the 10s. Now we're in the 20s. It's going to gradually run out of steam. We're already 2023, so maybe by 2025 it'll run out of steam. The theory being that it solved the contention issue. We didn't have enough resources. We couldn't stream properly because basically the bandwidth wasn't there, the processing power, the storage power. Now all of a sudden, 70% of people in many developed markets have over 100 megabits raw connection. That's enough to do any kind of video you might want. And processing power has continued to think. So maybe ABR, and I'm going to finish with that, Mike, hand back to you, is maybe ABR may have been the most amazing invention for the last 15 years. Maybe we don't need it anymore. We won't be needing it anymore soon, because there's so much raw power, raw bandwidth, that we can go back to constant bit rates, go back to the technologies we tried in the 90s that didn't work then because there wasn't enough, but maybe there will be in the future. I don't know. And this is all with the idea of sustainability, because one thing I don't like about ABR as somebody working in sustainability is all the wasted resources. Everything you do it 10 times or 100 times, with lots of all the different variations for all the different screens, all the different sizes, all the different bit rates and everything. Whereas, in the olden days, you just have the connection to one, but it would work out what that was. Maybe it needs to be multicast. I don't know, but so that's a disruptive idea. Maybe we can get rid of ABR in the next few years.
So Ben, this is a fantastic introduction, and I appreciate all the background and history and starting to talk a little bit about the problem. But could you share with the audience, really, if we look at sustainability and what we're trying to do with sustainability, i.e. decrease the carbon footprint across the world, can you quantify the impact of video on the internet? I think this will really kind of lead into probably Arian's discussion and the other gentleman's discussion of how we start addressing the sustainability issue. But from a scale perspective, how big is this problem?
Well, if I had clear answers to that, I'd be very rich, because I'm an independent consultant and I'd be selling that knowledge to. There's a lot of people working on it. I'm involved with the greening of streaming. I'm involved with the Ultra HD Forum, with the 8K Associate. All these people are asking this question and trying to work out the answer. So there's just some simple truths that we are beginning to get agreement on. There's no TV manufacturers on the panel, so I can say this, but the elephant in the room is often going to be the screen. Nobody seems, I don't know why people don't talk about it more, but it's probably about 70 to 80% of the problem is the device. And we really have to address this head on at one point, and everybody's sort of skirting around it for multiple reasons, because they don't own the data, because it's really hard to understand. So the latest study I'm aware of is the French ATEME last week. They updated, there's hundreds of studies all over the place. So the most recent data I have is 79% terminal device, 5% data centers, and the rest is delivering it over the network. So So say we solve the streaming problem and we divide it by 10, the resources required to stream, we will go from 15 to 1.5%. So we will solve the problem. That's my understanding is that, and I'm not speaking with any certainty. We're walking on quicksand. Things are changing all the time. The greening of streaming guys are doing an amazing job asking the real question is, what is the relationship between power and the video that we throw on the internet? And one of the issues, Mike, and this, which I don't, again, have a clean answer to, but it's no longer black. It's we're beginning to see an answer appear from the mist, is that it is seeming that the network consumes roughly the same, whether you use it or not. That is a big, big problem. That's a huge issue that we have to address in the heart of the network. So to answer your question, if I understood it right, Mike, today's best knowledge, best guess answer is about 15% of the problem comes from what we're going to talk about today. But I'd caution that with the fact that even if we do solve the problem, we have to solve it systemically as an ecosystem. No one person can, because just simply, even just removing a lot of the video from the thing doesn't actually save anything, because our capacity to deliver the amount of video we deliver today consumes power just by being there.
Yeah, so Ben, I appreciate the answer. Kind of where I was driving at is, how much content of the internet is video based versus everything else, and I think the number is probably pretty high. You made a comment earlier. Do we think we're going to go back to CBR? And I'm not going to steal anyone's thunder away from their conversation a little bit later in the series. But are we topped out as 4K UHD? Is that it? Are we really going to 8K? Are we going to see a difference there? Is there something beyond 8K? When we talk about the amount of content that's driven through the internet, I would imagine a lot of that has to do with the amount of bandwidth that's being used and the content that's being delivered. I do know that, compression technology is moved leaps and bounds forward, but are we at a point to where we think we can go back to CBR, or do we see everything continuing to evolve?
Just take that. My CBR comment was kind of a pinch of salt, was to kind of, take it with a pinch of salt. It was provocative. I don't necessarily believe that, but just a quick comment on that. So I can only speak on my personal behalf. I'm not wearing my Ultra HD Forum hat or greening of streaming or anything like that. As an expert, my strong belief is that we do need 8K because it's an artistic format. And if you say, well, actually, this piece of content, when I watch it in 4K and now I watch it in HD, I don't really see the difference. And I even less see the difference in 8K. So let's get rid of 8K. But actually, let's not even do much 4K anymore, because, I don't know, for watching the news, who needs 4K? And HD is fine. Okay. And then HD is my center of the thing. But actually, for talking heads, just the news, what we had in SD was fine too, actually. What do I need to see the details of somebody's skin tone or something with the news? So let's put news in SD. Actually, let's put news in black and white, because when you're watching somebody in the studio, there's no thing. Actually, let's get rid of the background. Where do we stop? So let's go back a minute and say, what is the point in the first place of doing any video? Any kind of film, movie, what's it about? It's a medium. Video is moving images with sound. We consider that's a medium. And there's a way of looking at it from 10,000 foot view. It serves one single purpose, video. It doesn't have any other purpose of being in the world. If it stopped existing video, it's a medium to take feelings from one place and give them to another person. You watch video and it creates emotion. That's its fundamental reason for being. Everything else you can probably do better. If it's just information, probably better with text or with a fixed image or whatever. Moving image, it's about emotion. And so moving image has a certain amount of characteristics. It has colors, it has resolution. And it's the artist's job. We as technicians have to let the artists capture, transmit, and display whatever they need, whether it's more resolution, whether it's more color, whether it's more dynamic range. It's not a technical job. It's not a regulator's job. It's nothing like that. And if, of course, you have to be reasonable, if moving from up the resolution ladder, you're moving from creating I don't know, in the lifetime of a device, it was going to create 100 kilos of CO2 and making it 8K, it's going to do 10,000 tons. Well, of course, no, we mustn't do that. But if you're talking about, which is the reality, we can see it today, the difference between 4K and 8K is relatively small in terms of carbon for transmitting it, for capturing it, for stuff like that. I don't think we have the right to say, well, we're putting the bar there and we can't have 8K because in that case, as I say, it's what I started by saying. Well, then there's no limit, and let's go and live up in the trees. So I do firmly believe we do need 8K. We will go to 8K eventually, not this year, but coming soon. In my lifetime, 8K will be a standard format.
So excellent feedback, Ben, and we could probably contemplate this conversation for a while and how important the artistic rendition of content is. But we're here to talk about sustainability, and I'd like to move over to Arian. Arian has, some ideas and concepts on maybe some challenges that we have. And with that, Arian, I'd like to turn the mic over to you.
All right. Yeah. Thank you, Mike. Yes, something about one year ago, I came to a similar kind of conclusion that Ben already presented. In the 50s, internet was designed having this prime requirement there, being able to communicate when half the country is being nuked. And now we use it for something completely different. We use it mainly to carry video. Something like 80% of the traffic is video. Today we are concerned about energy usage and sustainability. End of the 50s, that was not really a concern. And by the way, it was only going to be used by the military. So yeah, that it was never intended to grow as large as it is today. So if you take that into account and say, well, suppose we take another approach and we say, I want to design a network that can carry mainly video. I want to make it as energy efficient as possible. Would you then come up with the internet? And my thought is, no, obviously not. And then if you come to that conclusion, is it easy to get rid of the internet? Well, don't think so either. But can we optimize for 80% of the traffic the internet by redesigning that part only, so that for 80% of the traffic it is more sustainable? And there, well, I shared already some thoughts there, and I'm also very much open to other thoughts. But let me stimulate the thinking of the people here. So if you look to video, it has some particular properties. First, if you look from a router perspective, it takes forever. People are watching for minutes and minutes and even longer to video. So when it starts going, it goes. It's also very bulky. The amount of data is much larger than some other HTTP requests or other kind of banking applications that also run over the internet. Then there is another thing about video. It is highly predictable. In fact, your encoders that are being used can perfectly tell when the next package comes, and they can already predict it for quite some series. Also, if we use variable bitrate coding, because variable bitrate coding is not so variable that nothing can be predicted anymore. So if you take that into consideration, then suppose you have that knowledge in your router. You know, I have received a video packet. I know when the next one is coming. Then you can immediately forward that packet, the second packet, to the same port as you sent the first packet. And in fact, all this header information, you don't need it because you already know where it has to go. And this header information is partly being used for, giving the zip code of where this data has to go. So you can remove quite a bit from that. Also, what you see in routers and switches is that the data is coming in, it is stored in a buffer, headers are being processed, it's being put in an output buffer, and then it's being sent on the line. And of course, lots of optimizations have been done also in that area. But if you already know this is going to be a video bit that has to be output to that particular port, yeah, there is also no need to store that entire package over there. So that is my first lines of thinking of making video transport over a network more simple. And yeah, then there are, of course, many questions. How do you get that information into your router? How does it know? How does it know how to route it and things like that? But I think that is all secondary, which can be solved if the postulate that I say over here is really saving energy. And I think I will leave it for this moment at this point.
So Arian, yeah, appreciate you opening up some potential opportunities. A couple questions come to mind, initially. Obviously there's billions and billions of dollars being spent today in the development and deployment of internet across the world. And so if we're going to redesign the internet, is this something that, we're going to start from scratch again, or your thoughts that we can take some of the existing infrastructure and potentially change the way we do things as to not really impact everything that's been out there?
Yeah, so what I am thinking is, because what I describe is on such a low level, I find it difficult to believe that existing infrastructural elements can already do that. But infrastructural elements are being replaced every 3 to 8 years. So I can also imagine that you start with some isolated parts of the internet where traditional internet comes in. It goes in this new kind of router or switch. It does its magic trick that we are about to invent. And then some hops later, it pops out as regular internet anymore. And those islands are going to be connected slowly after technology has been available and it's proven to be that efficient and more efficient that I hope. It will, after 8, maybe 10 years, replace all equipment which is there, and then you have end-to-end delivery to all points using this new video transport protocol.
Wow, so general and wholesale forklift swap out of the internet and its infrastructure. I bet we're going to have a bunch of vendors lining up at your doors to figure out how we move this forward. Very exciting. Can you quantify a little bit on, how much you think you could really impact? And let's forget sustainability for a quick second, because I want to then relate it back to sustainability. But if we're talking about saving bits and bytes, are we looking at a 10% decrease, a 15 to 20% decrease? And then I would like you to then, and maybe we'll talk about this later, how is that going to affect sustainability from a perspective of reduction of carbon footprint, reduction of energy, and getting the content out there? Comment was made by Ben earlier saying, well, 8K, 4K, as long as we're sending it out, probably not much impact on the internet. And I'm probably over paraphrasing what Ben said and stepping on it in a little bit, but if you could address that, I would appreciate it. And then I think we've got about a minute or so before we need to move on to the next person.
Yeah. So the overhead in the headers information and in the that you have on Ethernet, on IP, UDP. It can vary. That is also one of the nice things about these protocols. But I think you can for sure save a small percentage over there in bitrate, which is not the real gain. The real gain is that you can go to an easier kind of processing where you need, speaking in CPU cycles, less CPU cycles to do the same. I personally believe that general CPUs are not going to be used for that. Dedicated silicons are going to be used for it. But CPU cycles is something that is easy to understand. And there I think you find the game.
Excellent, Arian. I appreciate your comments. Looking at time, I'm going to move over to Pieter. Pieter, let's talk a little bit about maybe some efficiency and where you believe, we're starting to address this issue of sustainability and potentially what we have looking in front of us.
Yeah, indeed. Thanks for having me in, first of all. Arian, very interesting line of thought. That said, I think you need to, and it's the comment that Ben also made, is that a priori, networks and network power consumption is not so much related to the real traffic that goes over it. Of course, you need to dimension your network to carry the traffic, but whether you use 10% or 80% of that capacity, it doesn't fundamentally change the power consumption, because at the end of the day, the network interfaces need the power, the RAM needs the power, and so forth. The same effect holds true for the servers that you use, and then now I'm already referring to basically a content delivery topology in a more traditional way, where you create a hierarchy of servers that are quote-unquote interconnected using the underlying network fabric at operators, or a larger setups like an Akamai, who is leveraging then a broader interconnected internet fabric. There equally, those servers, whether you use them at max capacity or somewhere lower, again, doesn't make any fundamental difference. Just to give you a bit of an idea, we ran this experiment, in fact, during the World Cup with one of our operator customers. And although from a traffic perspective, there was a 330% increase in traffic from basically the lowest point to the peak of the UEFA game. However, power consumption only varied 16% in the same window. So there is an issue of proportionality in terms of CPU utilization of, and specifically servers, and the power consumption. And that leads us to, at least from a Broadpeak perspective, to look at it, ways to maximize the utilization of equipment. So we recently announced a very high density CDN caching software, but associated hardware solution as well, in order to basically achieve that massive utilization of existing hardware. Additionally, you can start to look at what we call internally green orchestration, basically looking at cases where in the off hours, when the utilization of your caching service isn't very high, to re-aggregate, reassign sessions to one or a more limited set of servers, and simply turning off the other servers. That's going to give you the biggest saving in energy for that kind of setup. And then there is the additional approach, which was the main topic, at least that was attributed to me. Here is, and then I need to be very specific and talk about linear and live events, where especially live events are characterized by these very low utilization in the off hours, but potentially very high peaks during the busy hours, or during very specific football matches or sports events, which tend to be very popular during a very small window of time, which translates in a traditional approach in operators, whether they are public CDN providers or local ISPs, to basically dimension server capacity for those peaks. The alternative approach that we, from a Broadpeak perspective, have been promoting together with a number of other actors in the industry is to basically leverage IP multicasting. IP multicasting is in fact a concept where, like in the old days with broadcast, you sent everything to everyone, and basically you had somebody mentioned QAM, so a set-top box with a QAM tuner that then tuned into that program. In an IP multicast approach, there are different ways of implementing it, but the simplest to explain is that you do a broadcast and prune approach, meaning you're going to remove the delivery of those video packets for those parts of the network where there are no viewers. And that yields a priori a very efficient distribution mechanism for your, again, live and linear TV service. It's basically the fundamental mechanism used in IPTV by IPTV operators. But we have now enhanced this fundamental capability that is available at the router level to also carry adaptive bitrate and the segmented and variable bitrate delivery of video, which is now essential for a video service. And we carry this all over this IP multicast infrastructure in an extremely efficient way, because we only need to send it once and it is available to whoever needs to view it. However, at the edge, we have a little bit of a function that's going to mimic basically the QAM-based tuner, but in the IP level. So it's going to do what is called an IGMP join to basically request the reception of those packets. And then we have this internal function that does a translation into regular HTTP based delivery, which is then again unicast in the home. So that's a way to create an extremely scalable delivery of live and linear. And by the mere fact that we are not subject to those variations and peaks in the network, and we are leveraging an existing infrastructure, an existing IP routing infrastructure that is there running 24/7, consuming the power that it has to consume just to be up and running, makes it for a very efficient approach. That said, today the biggest challenge, and I think that's where maybe together with Arian and a number of creative minds, we need to push the boundaries, in the sense that today this technology is typically limited to the individual autonomous system, basically an ISP or a large carrier networks. In an ideal scenario, we have this inter-domain capability to do IP multicasting. And then we can transmit live video in an adaptive bitrate format from one side of the world all the way to whoever needs to and wants to watch that TV channel or live event. So extremely scalable. The good news is the routing infrastructure has it. A priori, we also have the protocols to do the interdomain routing and to the interdomain IP multicasting. However, we as a community should be pushing to enable this across all networks. So that's a bit my take on this. I hope it makes sense, and I'm here for answering any questions.
So Peter, first off, thank you for the very technical approach around multicast. I guess I'm wondering a little bit on, are you looking at getting multicast out to the edge, or are you actually looking at getting multicast all the way out to the subscriber? And can you talk a little bit to the challenges across
the current incarnation? In the current incarnation, it's all the way through to the subscriber, in caso the residential gateway or the set-top box. But whether it's a residential gateway or a set-top box, any device in that home can consume the adaptive bitrate as if it was originating from a regular delivery system. And it's completely transparent. So basically, you do not need to change anything to the player. The only thing we need to add is a bit of a discovery function to discover that there is this local server rather than that the player needs to go and retrieve it from the origin or the CDN cache that is closest by.
I would like to jump back in quickly and understand when we look at people's homes today, looking at IP multicast, it works pretty well from the initial router, but as we look at distributed mesh systems, these mesh systems aren't IGMP relays, right? So we have a problem with infrastructure in the home and really being able to support it to all the consuming devices.
You're absolutely right. It's a bit of a challenge, although not impossible, to deliver IP multicast over the Wi-Fi in the home. That said, we typically terminate the IP multicast on the residential gateway, and from the residential gateway over the Wi-Fi to all the devices in the home, we use HTTP, adaptive bitrate, HLS, or Dash.
Okay.
So that resolves that problem.
Okay. Hey, I appreciate it. And again, we're running a little short on time. Ben, did you have a question?
Yeah, just there's some questions for Pieter while we're talking about that, about the Delta Energy sort of, so whether it's in the home or in the network, what does a multicast ABR approach change to the overall energy impact?
A priori, virtually nothing, in the sense that it's a bit like with those servers and that example of the UEFA Cup I mentioned, whether you are having a lot of sessions or not, the CPU power consumption or the power consumption of the overall device remains the same. Just to give you an idea, a residential gateway that we looked at was consuming in let's say unloaded state 10 watt, and when fully loaded with max throughput for all download over internet, it was just going up to short of 12 watts. So again, the processing is not changing anything, and especially the processing related to this transformation going from the IP multicast domain to the unicast domain is from a CPU processing perspective somewhere between 1.5 to maybe 3%, but from a power perspective, it's negligible.
Dan, I want to give you adequate time to discuss your approach. Please go ahead and jump in, and for everyone else, we will cover these questions on the Q&A session on the sequential hour.
Well, thanks, Mike. I appreciate it. Yeah, so from an ATEME perspective, sustainability, carbon footprint has been a very important part of our vision. We are one of the founding members of the Greening and Streaming. Obviously, we've done a great deal of work from ATEME's known largely as a compression company. We've done a great deal of work to optimize the ability for compression to leverage the resources. Ultimately, we're a software company. And as Pieter mentioned, the goal is, from a software vendor perspective, is to minimize the use of the underlying hardware and server technology. The server technologies are going to continue to improve over time, and where our goal is to leverage that capability. So we've done work on the compression side to reduce the amount of power and be more efficient. As Pieter mentioned, on the CDN side, there's elasticity, where during peak hours, typically on-net CDNs are dimensioned for peak capacity. And during those off-peak hours, you can either, as Pieter mentioned, turn them off or not use them, or you could potentially reallocate those server resources for other non-real-time activities. For example, from an ATEME perspective, you could run in an orchestrated manner file transcoding, baud transcoding. Obviously, you can use those server resources for other capabilities as well. But we're introducing this concept called audience-aware streaming, because in the end, you've got the video compression process, you've got packaging, and then you've got CDN process. And each one of those components is largely independent. There's no kind of a relationship of data that impacts one side or the other. I mean, when you're doing compression, you've assigned an ABR bitrate ladder. The encoding profiles aren't really dynamic. There's really no knowledge of what's being viewed and delivered by the CDN. So one of the things that with audience-aware streaming is we're building a feedback loop from the CDN, which obviously knows what's being delivered and thus what's being watched from a profile perspective, and providing a feedback loop back into the encoding process. So imagine that you've got let's say 6 to 9 profiles of an ABR ladder, different bit rates, different resolutions, SD, HD, 4K. In our example, we didn't use 8K as Ben was talking about, but certainly that will get there. But imagine that you've got content. So in one scenario, let's say you're watching a linear stream that is showing TikTok video. So the target audience for that might be a little bit younger generation, might be watching on smaller devices, handheld devices, where another program might be using Peter's example, a football match or a soccer match here in North America, where you're watching it on the primary viewing screen. So you're watching it in HD or potentially in 4K. But so from a CDN perspective, I know exactly what's being delivered for that program to the various devices. And if I notice, for example, if I have data that says, well, profile 3 is not being viewed, profile 6 isn't being viewed, I can loop that data back into the encoding process and have the encoder, using some machine instructions kind of and learning perspective, adapt the ABR bitrate ladder kind of in real time and make modifications, potentially remove profiles, potentially adapt the existing profiles, change the resolutions, change bit rates, ultimately in order to better leverage and better utilize that CPU technology and processing power. How does that affect? You can potentially then allow more channels to be compressed on the same transcoding process. You're reducing the amount of content that you're distributing. You're likely using less bandwidth, but you're also using less storage, both from a CDN perspective, but also from potentially if you're using catch-up TV, restart, or DVR recordings, you reduce the amount of storage and thus reducing or better leveraging the underlying infrastructure. Ultimately, though, all of this is, and one of the challenges in our industry is, how do we reduce our power consumption? How do we reduce our carbon footprint? But as to the point that Ben made, ensure that we're providing the best quality experience for the end user, to gain the emotions of the video content. So ATEME, and we're really trying to focus on better leverage using our software technologies, either at the CDN side, at the compression side, optimize each of those standalone functions, but create this feedback loop so the data from what's being watched can actually impact what we're doing on the compression side.
Excellent, Dan. I think one of the things I heard, pretty importantly in your conversation is how do we better position content, i.e. looking at audience viewing habits so that we can effectively reduce the amount of content driven through the core of the network. Looking at some of the contents that are coming through the chat, it would seem to me that we are paying a lot of attention to the core. We've had a number of contents coming back saying, well, the core is not going to really change your energy distribution significantly. Do we really need to take this problem and look more at the edge and the consuming devices and understand how to drive power down there? And go ahead, Dan, please.
No, I mean, I'll reiterate something that Ben said. I mean, we did a white paper, ATEME did a white paper in 2019, and one of the data points was from the International Energy Agency was that, I mean, at that point in time, it was like about 72% of energy was attributed to the end user devices. I think Ben, may have better, more recent data. I think he said 78%. So totally agree that that the bulk of energy is at the end device. But each of us plays a part in the overall ecosystem. Whether it's Arian talking about the networking infrastructure, Pieter talking about some of the use of multicast, ATEME talking about the compression and CDN kind of functionality. Each of the vendors in the ecosystem have to optimize their own part of the solution. That's all we can do. But certainly we want to do things in a way that will allow us and allow the other parts of the ecosystem to better leverage and improve their part of the ecosystem.
Excellent, Dan. And I think you brought out a good point. When we look at the home, and I don't remember if it was Pieter or Arian that talked about the consumption of home routers today. And we look at the new Wi-Fi that's coming, we're not talking about 10 to 12 watts anymore. We're talking about 20, 30 plus watts, really to allow for the end user to be a little bit more comfortable in streaming content. And whether that's video content or other content, again, we continue to drive power at the edge without the understanding of impact, specifically to placate users that want to consume without barriers. And Ben, I don't know if you want to talk a little bit to that or your thoughts, or gentlemen from the group today, before we jump into our question and answer session. But I think the end user, their consumption, their habits, do they really care about sustainability, or are they more concerned about just getting access? And is this an uphill battle that we're going to run up against? Ben, please.
Yeah, so just a quick thing on that, and I want to do the other question. The quick thing is, my understanding is when it's the same issue as introducing new technology. You kind of segment your audience into three groups, and you have, the front leading early adopters, the people who, so in our case, who will care and will do stuff. It's about 20% in most markets. Then you have the kind of general, most people is about 60%, who maybe they care. You have to talk to them about it. They're open to the thing. And you have about 20%, same as the other extreme, who say, screw you, I'm not interested in any of this. I want the best possible service for the least amount of money. So I think that's a marketing question department. But I just wanted to go back to the previous thing where you made an excellent comment, Mike, saying that when you kind of read through everything that we've got in the chat, lots of interesting information. People are saying, well, let's not focus just on the core network, what happens at the edge. And I'm involved with multiple organizations, as I said in the intro, and there's this kind of gray area. I talked about the elephant in the room earlier on. Dan was saying 72%, I said 79%. One of the big issues, which Arian's approach also to going back and going to see vendors is just simply, historically, over the last decades, users haven't cared that much about the energy consumption of their devices. When you plug something into the wall, if it's going to save a few milliwatts left right here or there, you don't care, because you're plugging it in, turning it off, and that's the way they've been designed. As soon as you have a mobile phone, every milliwatt of consumption is carefully, Apple is fighting with Samsung, who's got the best mobile phone, and one of them is its battery life. And so that we could do it technically, but as soon as you get something that plugs into the wall, you don't do it. And one of the issues we have, and this is something that everything, whether it's Dan's approach, Pieter's approach, or Arian's approach, what effect will it have on the end device? The unfortunate truth today, as I understand it, is probably almost no effect, because they're really dumb, the devices. So it's typically in the chipset of a set-top box, say, in the chipset, there's a part of that chipset, its reason for being is to decode video. And because nobody cared tuppence about a few extra watts here or there, it has a function of being on or off. And so when it receives a video signal, it goes on. And it usually stays on in case another video signal might come. But whether that signal, we've spent months fine-tuning it to try and make the video signal require less power to decode, to use less space in the network or whatever. A lot of the things that are used that are most power hungry have a functionality of being on and off. That's true for video decoding, not encoding. So, I mean, correct me if I'm wrong, Dan, you're an encoding person, but I believe that an encoder, the power it uses will depend on the power of on the complexity of the work you give it to use. But the decoding function has no variability. And another really bad elephant in the room is the Wi-Fi network, because a lot of the Wi-Fi of the streaming going on in people's homes actually goes to Wi-Fi. Even if they have connected TVs, they'll connect them with Wi-Fi. And Wi-Fi, just like the decoding function, has this functionality of being on or off. That's it. And that is a huge problem.
Ben, Peter, Dan, and Arian, thank you so much. I appreciate all the content and exposure. I think the questions coming up will be very entertaining, at least technically, and looking forward, I think there's a lot of work to be done here.